questions do we have? Want to go over on the shark bite? So I saw 1 and 4 the most, and then some 3, so we'll do those 3. And many of these 3 can be done on Desmos. Starting with the first one, I just realized that some of these say number 2. Anyway. For number 1, if we were to put these into a table, I could look at these points and see what are they doing. They seem to make a line that goes to the origin, so that's telling me it should be direct, but all of the constant k's, the slope has to be the same. So this is negative 1/5. If I go over, go down 1 to the right 5, that's the same. If I go to the other side, go up 1, left 5, that is also the same. So it is direct. And then it asks you to state the correct variation equation. So our direct equations are y equals kx. We just found the k to be negative 1/5. So that equation would be y equals negative 1/5 x. If you're putting what I'm putting, make sure you're also putting use Desmos to get full credit for those. Questions on that one? Number 3, which points are not solutions to the inequality graph? If I were to plot these points, we have negative 2, 4, 0, 3, and 5, 1. And we're looking for the ones that are not solutions, so that don't fall in the shaded areas. So negative 2, 4 definitely does. 0, 3 falls on the line, but it's a dashed line, so that would not be a solution. And then 5, 1 is not in the shaded area, so also not a solution. So you should have those 2 written down. And then number 4 can be done on Desmos. I'll show you that afterwards, but you could really just use the graph. You could also do it algebraically. So if we're looking for the equation that passes through this point for negative 1 and has a slope of negative 3 over 2, if I go up 3 and left 2 and I keep doing that, I end up on the y-axis, and then I could write my equation. Y equals negative 3 over 2x plus 5. So I have to You could also use your point slope formula, do it algebraically, and find that out. If you were doing this in Desmos, you would need to put in the ordered pair. Type in your y equals mx plus b. Add in all your sliders. Change your m value to negative 3 over 2. And then move your b until it goes through that point. And then you have your y equals mx plus b. Y equals negative 3 over 2, x plus 5. So if you use the graph, use graph. If you use Desmos, make sure you put that. If you did it algebraically, I'll be able to see that. Questions on that one? Make sure your name is on your answer sheet. Go ahead and turn that up. Pass that up with you. Make sure you're writing this stuff down. Remember that all of your inequalities can be done on Desmos, so if you type in and you're looking for systems, you're looking for the order pair or the coordinate pair, that would be a solution. So if you graph these two, for 2, B was your solution for 5. C was your solution for 6. 7, you had to graph the inequality, the system of inequalities. So you could have done that on Desmos or actually done it by hand. And you'd have this overlapping area right here. And then the next 2 questions are related to this. Name 2 points that are in the solution set. This could be from this or not. It doesn't matter. So your points don't have to match mine. They could be any 2 points in that shaded area. And then you had to select which of these were also part of that solution set. So of the ones that were, there were only 2. -4, 2, and -4, 4. And then go on to the next page. You don't need this work, but if you want it, you're just putting that into both. So, for whatever reason, this is not showing the problems. So number 8 was 3, 1, 1, 3, -1, 4, 3, and 6, 0. Number 9 was -1, 6, -1, -6, 0, -5, and 0.5, -2. And 10 was B. Anyone need me to repeat which ones those were? Really quickly, I'm going to show you how you would check this in Desmos. All the systems ones, all the inequalities ones, graph those, put the points. You can look and see which one falls in the shaded area. Even if it has multiple, you can look and see which ones are in the shaded area, overlapping shaded area. Remember, if they fall on a solid line in that area, double check it, but it should also work. I think the other ones were the same. They just have different ones. Okay. This is not a over spring break homework assignment because you could get it done this week. But the next time I see you after spring break, the SOL things that are due are SOL A6A and 6B. 6A and 6B. Again, not homework assignments to do over spring break. You are welcome to do that if you so choose, but you could get them done this week. A6A and A6B. And then that will be the last informative SOL practice. The last 2 will be formative. So keep that in mind. Take out your factoring notes and go to the second page. Anyone else need another copy of this? I'm waiting on this to reopen. Go to this page. This is the second part part of the Delta Math that's due this week. Remember that your Delta Math for this unit are formative. Okay, let's try this warm up and then we'll talk about the rule and then we'll get into some of the other ones. If I were to simplify these, I'd be multiplying these using your FOIL, your box method, your double distributive. So if I multiply this out, x times x would give us what? X squared. X times negative 4. Negative 4x. 4 times x. 4x. And then 4 times negative 4. Negative 6. And then when we combine like terms, what happens there? The x's cancel out. So we would just have x squared minus 6b. Right, let's keep going. 5m times 5m. What's 5 times 5? 25m squared. 5m times negative 1. Negative 5m. 1 times 5m. Plus 5m. And then 1 times negative 1. Negative 1. And if we combine our like terms, what would we have left? 25m squared minus 1. Alright, last one. 2a times 2a. 4a squared. 2a times negative 3b. Negative 6ab. 3b times 2a. 6ab plus 6ab. And then 3b times negative 3b. Negative 9b squared. And when we combine our like terms, what would that end result? 4a squared minus 9b squared. So we're going to be given a lot of things that look like this and have to write it in this format. Kind of like our GCF working backwards. So this is a different type of factoring. It still falls under the umbrella of factoring. When we're doing this, one, we have to make sure that we actually have a difference of squares that we're subtracting, not adding, because it won't work. Then, if you see something in this format, you're going to have two sets of parentheses. And you have to think about this like, what times what will give us a squared? A times a. So you're going to put that first in both. What times what will give us b squared? B times b. Put that last in both. And then put a plus in one and put a minus in one. This is how the difference of squares looks.
You always put a plus and minus?
Mm-hmm. 1 plus, 1 minus. It doesn't matter which one. Because if I were to multiply this back out, a times a gives us a times negative b, negative ab, b times a, I'm going to write it as ab, but sure, yes. B times negative b, negative b squared, and if I combine like terms, so we want to get that end result every time. This, again, is an optional step. This is to check your work. You don't have to do this, but can if you so choose. So now that we know how to set this up, let's try some of these. So this is subtracting, so we're going to use our difference of squares, set up our two parentheses.
So there's subtraction two parentheses.
If you see adding, it wouldn't work. You couldn't do this at all. It would be prime, or you'd have to find a GCF. Okay. A times what would give you a squared?
A times A.
Ignore the negative. What times what would give you 4?
2 times 2.
Times 2, put a plus, put a minus. That's it. That's why I said this one is probably the easiest one. Alright, let's do 2. What times what will give us n squared?
N times eight.
N times n. What times what will give us 64?
8 times 8.
8 times 8, put a plus, put a minus. 3, 9 times 9,
X.
and x times x. Put a plus, put a minus. Now, notice that this one looks different than the other two. Whatever the order is has to be the same in the factors, but the process is still the same. So then what would 4 be? What would the factors be? So when I say, what are the factors? What is this? What is this? What are these two?
There.
Sorry. What would the inside of this be?
And a crazy
I did
number.
With what letters? With what
C.
numbers?
C and
C plus 10 and C minus 10. Those would be the two factors that multiply to get this.
Basically what I said.
So would I flip them on my like C minus 10?
Yes.
Okay.
It doesn't matter which one is plus, which one is minus. The only thing that matters is the order that it's written in has to be the same. So if a variable comes first, variable has to come first. If a number comes first, a number has to come first. With number 5, could we do that one?
No.
No, that would be prime because it has a plus. You don't. Let's jump to 7. What would those factors be?
A
3,
oh,
B,
what did I get?
plus 10, and minus 10. Question so far? Let's do 9. What would those two factors be?
4.
Plus, minus, it doesn't matter.
Plus 11.
11.
4.
Correct. Alright, let's do 1 with 2 variables and then jump into some harder ones. 11.
2 H minus 5 G
And the other one?
2 H plus 5
Alright, go on to the back.
Wait.
Alright, now we have some exponents that aren't 2, and we have more variables. So how would we do 13?
X Y plus 1
And
X Y
good. What about 15? I think we're supposed to be 25. Ignore that. If we go on to 14, when you see an exponent that's not 2 and it's even, just divide it by 2.
9 and 2
9n squared
plus 5
and
9 squared minus 5
17.
K A cubed
K to the third or k cubed, yes.
minus
4 and
K cubed plus 4
plus 3 plus 4, yes. Sorry. Right, and then 19.
11 R cubed
11 r cubed
minus 1
minus 1 and
11 R cubed plus 1.
do we have any questions at all on how the difference of squares work? add a step. If you see two terms, binomial, if you see a binomial, it's one of two things. Either GCF or difference of squares. Sorry, it's one of three things. Or it could be a mixture of both. A mixture of both. We're going to try some of those. So in any of these problems, whatever your problem is, you should always be checking for GCF first. So remember from Friday, GCF is what could we divide out of both of these. And I didn't show you how to do that on the calculator. I'm going to do that today. In your calculator, go into math. Scroll to the right for number. And then go down to number 9 for GCD. That's greatest common divisor. Greatest common factor is the highest thing you can divide out. It's the same thing. So number 9. And then you can put two numbers in here, only 2 at a time. So the 2 that we just had were 2 and 72. Ignore the negative. So 2, 72. And it would tell you what that GCF, GCD is. If you have a similar function on Desmos, remind me at the end. I will show you how to do that. So we can divide these both by 2. What would be left? N squared minus divided by 2. 36. Can we do anything else with this? So we can't do GCF. What about difference of squares? Yes, we can do that. What would those two factors be?
How are we supposed to know that?
Plus 6 and n minus 6. You have to look at this and see, could I take something times something to get n, and something times something to get 36, the same thing? So you have to be practicing this, trying these out, seeing if you can use both. So when you finish this week's Delta Math, you'll see some of these also. Let's go on to 23. Find what would be our first step. GCF, okay. Does it have one? If you're not sure off the top of your head, you can either list out the factors of 32 and 18 or do what I just showed you in the calculator. Math, go over to number, GCD, 2.
4.
4 is a higher one. 2 would work, but 4 is higher. Sorry, not 4, because 18 doesn't go. 4 doesn't go into 18, so 2 would actually go. Oh no, it's 2.
Said that.
That's okay. So if we divide these both by 2, what's left?
16.
S squared minus 9. U squared. Can we do anything else with that? Yes. What? The difference of squares. Okay. What would those two factors be?
4s.
4s. Plus, okay, 3 point u. And 4s minus 3. So if you're not sure about what times what goes into these, take the square root of these numbers. Let's do 27. Find the GCF of 80 and 125. 27. And do they have anything else in common? And how many?
2.
2. So we can take out 5n squared, which would leave us with
4.
divide 80 by 5.
I mean, someone.
16. Okay.
Thank you. 16 n to what power?
Squared.
Squared, yes. Minus
Are you taking my
dividing it, yep.
5.
25. Would you have any n's?
No.
They both would cancel. Can we use difference of squares here?
Yeah.
Yes. What would those two factors be? Four n minus 5 and 4n plus 1. If you have n's or variables in common, divide that out with your GCF. If you see odd powers of variables, you have a GCF with variables. Okay? Remember that you have your Delta Math that's due on Friday. That is formative. You guys can keep practicing in the notes in Delta Math for a little bit, but the bell will be ringing here in about 6, 7 minutes.